Experiment 4 involves chromatography. I know you have seen chromatography before, so let me just show you an example. Maybe you've been watching some crime show like a CSI or something like that, and on a computer screen or maybe on a printout, if it's an older one, you see something like this, and they say something like, this represents the gasoline that was found at the scene of the crime or at the scene of the fire, and this is the pattern of the gasoline found in somebody's garage, and therefore this gasoline from the crime came from the same place as this gasoline in the garage. Does that seem familiar? Well, that is chromatography. Sometimes in chromatography you end up with something like this that has peaks. Sometimes with chromatography, like in ours today, you'll have a piece of paper that will have a pattern of spots instead. But in either case, each peak represents one substance. So this one has 3 different substances. And in this type, each spot represents one substance. And you can also kind of see something about the relative amounts of the substances present. The order has meaning as far as the properties of the substance as well. Anyway, chromatography is used not just in crime labs, but in environmental labs, research labs, quality control labs, a lot of different types of chemistry labs, for sure. So the thing is that even though we define chromatography as a method to separate a mixture, separating the mixture is not always the purpose. It's also used to identify a particular mixture or substance. Sometimes it's used in combination with another method of detection. It depends, chromatography depends on differing solubilities. And another way to say that is differing attractions. We're talking about attractions from one molecule to another, or ions to molecules, attractions between particles. All chromatography involves a mobile phase. The mobile phase needs to be a fluid. Fluid means it's a gas or a liquid. It flows through the solid phase. So the way this works is that some components of the mixture you're testing will dissolve better than others. And when we say dissolve better, what we're really saying is have stronger attractions to. Okay, anyway, so it's always a fluid. It flows through the stationary phase. Our mobile phase is called the eluting solution. The stationary phase is a solid. It's porous, and the mobile phase will move through it. Again, this is about attractions. When we're talking about how well the components of our mixture that we're testing stick to or adhere to the stationary phase. It's generally a solid. Sometimes it's a liquid attached to a solid, but we're not going to get into that. Our mobile phase is paper. Elution is the process of washing away with solvent. So we will be doing elution or performing elution when we leave our paper sitting in our solution and it slowly soaks up the paper. We'll look at that in just a second a little bit more. The RF is basically a measure of how far up the spot travels compared to the solution. And when I say the spot, we're talking about a particular component of our mixture. The RF, it stands for retention factor. And it's measured by the distance that the spot travels divided by the distance that the solution travels. This is the component, the distance the particular substance travels, divided by the distance that the eluting solution travels. And we'll do a sample calculation here in a minute.